Well, hello, everyone. Thank you for joining this special Magstim webinar today. I'm Ronnie Stella Campo. I'm the CEO for Magstim and its parent company, Welcony. We also have the EGI product line and the Technomed and Neuroscience products line. But today, we're really focused on TMS. I want to extend a thank you for all of those who are out there doing what you do to help improve the lives of patients through critical research and life-saving clinical work. So for those of you who may not have been on a Magstim webinar, Magstim Academies before, just want to let you know Magstim was the first TMS company. We were founded by a group of UK researchers who identified the impact of magnetic stimulation on the motor cortex. And we continue to be driven by research, by a desire to help people, and we want to develop various neuromodulation technologies that help you answer your research questions as you drive innovation to alleviate pain and suffering. Today, we have our principal innovations engineer, Majid Memarian, and he's going to share his new white paper outlining how the novel Magstim Sham Coil technology offers a valuable tool for your TMS research. Following Majid's presentation, John Leadham will be managing and monitoring the questions and comments coming in. So start submitting your questions. For those of you doing clinical research studies that include TMS, controlled studies provide a critical framework for investigating the true impact of neuromodulation. We use it clinically. We've used neuromodulation clinically for a long time. I don't think we've ever really answered the research questions. So Magstim is dedicated to helping you do just that in various modalities across various clinical research, primary research, and translational research areas. Dr. Memarian is committed to finding and developing technologies that enable you to do your best research. It's really inspiring to me and the Magstim team to see this innovation come to life. So brief question and answer session at the end. Use the chat feature for your questions. However, now comes the boring part. Before we start, I just need to read this brief statement. Scientific content remains the intellectual property of the authors. This webinar is sponsored and organized by Magstim EGI. However, Magstim EGI does not engage in generating or editing scientific content presented. Inclusion in this webinar should not be taken as an endorsement of scientific findings by Magstim EGI. Please note the use of Magstim devices or EGI devices for other than cleared intended uses is considered investigational. So now the attorneys are happy. And with that, I happily present Dr. Memarian. Thank you, Majid.
Thank you, Ronnie. Thank you for your introduction. So I'm going to share my screen. Yeah, I cannot click share my sound. So interesting. Okay, I will start. Maybe there is an issue in the sharing the sound because I have some clips to play with them. So yeah, okay, that's fine. Okay, I hope you can see my screen now. So yeah, so hello everyone from the beautiful city of Whitland, UK, where Magstim's main site is located, and welcome to the Magstim Sham Adaptor webinar. We are excited to introduce you to the new Sham Coil technology. So as you know, Sham coils play a crucial role in research studies as they enable the control groups, blinding, and more importantly, the separation of treatment effects from potential biases and also placebo effect. So let's explore in just 9 slides how this innovative tool will help researchers to minimize the placebo effects. Okay. Okay. So I may minimize this one. Yeah. So as you know, all TMS coils have both on-target and off-target stimulations. On-target stimulation is a desired effect, while the off-target stimulation is considered as an ancillary effect of TMS. So these effects refers to the unintended or undesired stimulation of the head, the brain regions that are not primarily targeted. We can divide these ancillary effects into two parts. So the first one includes the stimulation of the scalp, which might also affect facial muscles, and off-target brain stimulation or neighboring brain areas because of the magnetic field spreading all around the target area. And the second one involves stimulating the auditory cortex through the sound of clicking. So the concept of ideal sham coil is clear. The sham coil should be designed to mimic the off-target effects without any direct impact on the targeted brain area. So it's necessary to evoke the tactile sensation on the scalp and also creating a convincing interaction between the coil and the participant's head. And also the auditory elements is crucial as well, imitating the clicking noise associated with TMS. But what made sham coil even more interesting was the concept of double blinding. Not only did we strive for it to be blind for operator and ensuring unbiased operation, but also for patient, eliminating any knowledge of whether they were receiving active or sham stimulation. This would also minimize the placebo effect. And finally, if possible, active and sham coil had to be a single coil to simplify the process, avoiding the need for coil repositioning, reconnecting, and the complexities of readjusting neuronavigation tool, all because of the coil change. Okay, if you conduct the literature search for TMS coil, TMS sham coil, you may find three main parts or three main categories for sham stimulation. The first one is the coil rotation. Imagine your target is an M1 point and you want to have a sham stimulation. Instead of putting the middle of coil on the M1 point, you just put one loop of coil on the M1 point. So, or you can rotate it with 90-degree or 45-degree. So the questions are for this method for sham stimulation is first, definitely it's not blinded for operator. Operator can see what's applying. And also we need to model the off-target stimulation. Is off-target stimulation for these are similar to the off-target of the real stimulation. And also the neuronavigation is other things. If we rotate the coil, something like this, can neuronavigation device track the coil position? So they are critical questions need to be answered. The second way is using null feed and the sham pad. So normally they disconnect the coil from the stimulator and put the coil on the target point and just to apply a little bit pressure on the head of participant. Then run one noise generator device just to mimic the clicking noise. But as you know, if the coil is not connected or they use empty coil or fake coil, there is no scalp sensation. So they need to use some electrical current to induce or evoke some tactile sensation. They call this method as a sham pad method. So some serious questions are here is first, how should I adjust the intensity of current I'm applying for a sham pad? Where should I connect the sham pad? Should I connect them on forehead, which is easy? Or if my target, for example, is dorsolateral prefrontal cortex, can I connect the pad on the head? Because someone like me may have some hair on their head on the target area, so it's not easy to connect the sham pad. The other question is, if I want to do TMS EEG simultaneously, can I connect the sham pad just under the EEG electrode? So is there any extra artifact because of sham pad? Also other things is like losing the EEG electrodes connection and many other issues would be with this method. The third method, which had gained popularity, was the use of double-sided coil. One side delivered active stimulation, while other side is for sham. So if your neuronavigation tool is just in the middle of coil, so it's very challenging to adjust this one. So if you are lucky and your neuronavigation is on the coil holder, maybe you can put the sham side on the participant head, but there is a big challenge to track the neuronavigation when it's under your hand. Or you need to relocate the neuronavigation sync. That means you need to recalibrate the coil and recalibrate the neuronavigation tools. Also, the sham side has no sensation, would have no sensation on the scalp. So you must use the sham pad as well. So when you use sham pad, all complications of sham pad became a significant concern. So this method also, for me, it's not a very feasible method to induce a sham stimulation. So, but what's the Magstim solution for this one? So we use exactly same figure of 8 coil as a sham solution, but we just change current of one of our loop instead of keeping same for the active or standard figure of 8. As you know, in standard figure of 8, in one of the loop, the current is like clockwise, other one is anti-clockwise. In the sham solution, we have both are in the same current direction, which would, let's say, cancel out the magnetic field in the sweet spot of 2 coils. The good thing is, with this method, you don't need to use 2 separate coils. You can have it one single coil, and just by changing the adapter between the coil and the stimulator, you can change the stimulation state from active to sham. So let's take a look for some modeling I did on the Coil software. So for the active one, when the currents are one in clockwise, other ones anti-clockwise, a stronger and more focused electric field is generated due to the superimposition of the field at the intersection point. The field penetration is very clear in this approach. So if we look for this sliced head model in Coil, we can see the activated area or penetration depths by a real one. In the case of sham stimulation, with the central region, the electric fields generated by 2 coils mutually attenuate each other. So this causes a lack of effective stimulation or any penetration depths on the deeper area of the brain, as we can see in here. However, in the areas located below the coils, which we can say on the scalp, we would have some sort of electric field, which can cause some tactile sensation. So I also reached out SimNibs developers, and I asked them to create the SimNibs model for this real and sham state of Magstim. So here you can see one example of this. So what I did is I adjusted the coil in the software to the F3 point, which is the dorsolateral prefrontal cortex, and applied the same intensity for the active adapter and also the sham adapter one. The outcomes were very similar to the Coil modeling. In the on-target area, there is no electric field for the sham adapter, but all around the on-target area or off-target area, the electric field would be similar to what we will have in the active one. So we believe that the sham coil could effectively mimic the off-target stimulation. So the best part is we will make these models available for everyone to access and experiment with. As far as I know, this is the first TMS coil with both active and sham models in SimNibs. So for your own research, you can now model the sham effect and make your claims more robust in your research or in your proposals. Okay, also for cross-validating, we did some practical measurement with 3D pickup coil. So very quickly, if I want to explain here, we have, let's say, 3D visualization of the measurement we have on the region of interest. Each sphere represents 5 millimeters. For active adapter, we can see that we have the strongest field on the middle of the head and also very good penetration in the depths of the head. But for sham, we have just very shallow magnetic field just on top of the head. But in the deeper area, there is almost nothing. To better look for the penetration depths, here you can see the coronal crosscut from the measurements. So this one is for the active and this one is for the sham. Each square represents 5 millimeters. So for the active stimulation, just under the coil and in the targeted area, we can see we have a remarkable electric field. However, for the sham one, in the deeper area, there is almost nothing, very, very low induced electric field. But we have some sort of electric field on the top of the head or on the scalp. This one is the ratio of the real electric field divided to the sham one. So when we are close to the head surface or the scalp, the ratios are around 1 or 2. That means the electric field is similar to the real one. But when we go for deeper area, like 1.5 centimeters or 2 centimeters, there are big differences between real and sham. So that means we do not expect any neuromodulation effect for the sham coil compared to the real one. Okay, I can go, yeah. So here we have a setup just to visualize what we can do for active and sham. So what you can see here, we have 2 pickup coils just on the scalp. They just mimic the scalp receptors and they connect to the green LEDs. And also we have one other pickup coil just in the head, 2 centimeters below the head surface. This one models the treatment target. So we use horizon device, AFC coil, and we change the adapter from real to sham. And we will see that in the next one. When you have a real, all 3 LEDs would turn on. That means we would have a sensation on the head and also stimulation in the target. But for the sham one, the middle one, the pickup coil inside the head would be off, but the scalp receptors one would be on. Okay, first I'm going to run the active one. So the protocol here is 1 Hertz. We applied 6 pulse. Probably you couldn't hear the sound because I couldn't share my sound. I'm sorry for this one. Now I will play the sham adapter. So the difference here we saw perfectly demonstrate our expectation. Similar scalp sensation for active and sham adapters, but almost no penetration depths for the sham adapter. Okay, finally, I will play a video we did to MEP measurements. I can go out, yeah. Okay, I'm going to talk about each part, what we are doing here. Okay, so we have an easy coil connected to horizon device. I adjusted the coil on the motor cortex M1 point, and I connected the MEG electrodes on the FDI muscle just to measure the MEPs for the real adapter and also the sham adapters. We will see the MEP values in here for both adapters, and we can compare it. Also, if you take a look for the finger twitches, so you can see that they are very visible finger twitch for the real one. So first I connected the real or active adapter. So it's very easy to connect it. No need to turn off your device. No need to do any adjustment in software. Just connect it to one side of your coil, then connect to the horizon device. The intensity I applied is around the motor threshold, so we do not expect to see all very visible twitch because it's not very higher than the motor threshold value. But when we look for MEPs, we can see very clear one just in here. Yeah, this is the first MEP, second one, third one, fourth. I try to have 2 or 3 seconds interval between the pulse and apply them randomly to have to minimize any plasticity effect. Now I will swap the real one with the sham. Yeah, this is the first one. Second one. Yeah, if you look for the value in here, they are all in a microvolt, so very, very low value. What we are seeing here is all artifact because of the TMS pulse. There is no muscle response. Okay. So yeah, just to wrap up. So the key points for Magstim new sham solutions are, first of all, you will have one coil, single coil for both your active and sham stimulation. You can keep it in the same position for both coil. You don't need to swap anything. Just you need to change the adapter to go from active to sham. The scalp sensation would be similar for the active and sham. Clicking noise are almost identical. We couldn't hear in this presentation, but I'm sure you will see on other videos we are going to, let's say, make them available for public. You can hear that there's no difference in the clicking noise. Also, it's very suitable for double blinding studies because the operators cannot understand from the sound, or even they put their hand under the coil. It's very hard to say which one is real, which one is sham one. And finally, the SimNibs models are available. Just reach out to us. We would be happy to share it with you. Also, in the next version of SimNibs software, it would be in a default library for the coils in the SimNibs, so you can easily use it. If you want to read the white paper, just scan this QR code here, or if you Google Horizon Sham Adaptor, you can find all the related data. Yeah, John, that's it from my side. So if there are questions, just ask me.
Dr. Memarian, thank you so much. I'm going to turn it over to John Leadham now to take and moderate questions. Thank you. Awesome, awesome job given the technical difficulties, Majid.
Thank you.
Thanks very much, Majid. That was fantastic. I'm really excited about this coil. I think it, you know, being out in the market all the time, I think this coil addresses a lot of the issues with sham coils. I do have a few questions for you that have come in, and anybody else that has questions, please put them in the question and answer, and we will try and get them in here in the last few minutes as we go along. First question I had was, what method was used to compare the clicking sound between the true and the sham conditions of the coil?
First thing, we use sound pressure level. We measure the sound pressure level for single pulse and also for the ITBS protocol. We compare it for 20 times. We repeat this experiment for 20 times. There is no statistically significant difference between the sound pressure level between them. Also, when you take a look for the electric field shape in the output, the difference is lower than 5%. And this one is because of the mutual inductance of two loops inside the figure of 8 coil. Also, we asked 10 people to, can you distinguish which one is real, which one is sham? And the 10 people were really expert in the TMS field. So we couldn't, they couldn't distinguish it. So we believe they are, the sound, clicking sounds are totally identical.
Great, thank you. This is a clarification from me, but we showed the single stimulus version of the coil. Just confirm that it can be used for RTMS as well.
Of course, yeah. We in the first release, which is released now, so two versions of coils are available, AFC version and also easy cooled version. So both coils are active cooled version. So that means you can apply any treatment protocol like 10 Hertz or ITBS or anything you want.
Thank you. What was the biggest challenge in designing a sham coil? Which aspect of it gave you the most difficulty?
Good question. The main thing is trying to evoke tactile sensation on the scalp, but without any penetration in the head, penetration on the brain. It's the main challenge. So if you wanna give more tactile sensation, definitely would have impact on the brain, would have neuromodulation effect. So I try to model it in COMSOL and in SIMNIBS and make sure that the neuromodulation effect for sham state is minimal. So that's the first thing. The second challenge is using the single coil. If I had options to have two coils, one for real or active, one for sham, everything would be more easy. But we decide to have a single coil, give people just using a one coil for active and sham. So that was the second challenge for me.
And can you reiterate, in your presentation, you talked about some of the other benefits of having only a single coil when you're doing this research. Can you just reiterate those?
Yeah, first thing is neuronavigation tool. You know, when I was postdoc researcher, we did some human experiments. So every time we want to change the coil, we must change the neuronavigation tool. We should recalibrate it, do something in software, really big delay, and let's say annoying procedure for me to do it every time because of changing coil for any reason. So if it's just single coil without changing the neuronavigation tool, it's a big benefit for me. Also, the maintenance thing, if you have just one coil, the maintenance things and keep it in a place is more easy. Fix with coil holder and don't change it is another things. You know, the TMS coils needs to fix it because you need to apply treatment for, let's say, 3 minutes, 4 minutes, or if it's RTMS, would be 30 minutes. Adjusting it in a coil holder, fixing the coil holder is a little bit challenging, but if it's just one coil, it's easy to fix it and continue.
So eliminating as many variables as you can then, effectively.
Of course.
What does the Magstim sham coil do that's maybe unique from other sham coils out there?
So I believe first thing is the single coil, no need for coil rotation. This is very important. Second thing is, I do believe SIMNIBS models are very important. You know, SIMNIBS software is very easy to use. It's designed for using almost everyone. You don't need to be engineer or professional with modeling it. You can easily select your head model, select the coil position and run it and see the result. So I think it's a big positive point for Magstim sham to be able to simulate it before applying any sham protocol.
And do you have any best practices or advice that you would give to people using your sham setup?
Yeah, the first thing is, you know, for the standard adapter or active adapter or real adapter, it's not necessary to use adapter. That means you can directly connect the coil to the TMS stimulator. If you do this, the coil would be like a real or active one. So for finding the motor threshold, the best thing is not using any adapter if motor threshold finding is not part of study. It's just for finding the threshold, then applying the treatment. So they can directly connect the coil to the stimulator, then move the coil to the targeted area, then use the adapter, active adapter or the sham adapter to applying the protocol they want to do. The second thing is we did not write the type of coil on the adapter label, but they are part numbers. We must give the part numbers because of the regulatory things. So if operators are familiar with part numbers, because they can find in the user manual which part numbers for real, which part numbers for sham, operator may find which one is real, which one is sham. My second suggestion would be covering this. Normally there's one person who is, we can call it as a study, let's say, yeah, someone managing the study. That person can cover it. First write which one I'm giving to this operator, then cover the label, then give it to the operator. That would minimize the bias because of the operator, or placebo effects because of the operator.
Okay, thanks. I think that answered another question for the most part that just came in. Let's see, I had one more written down here. Why are the sham coils so important in clinical studies?
Yes, very good question. Especially when you're doing psychiatric research, you are trying to apply any treatment for psychiatric disease. The environmental effects are very important. So we must make sure that the treatment we are giving to patients, the result we get because of the treatment is just solely because of the magnetic stimulation to the targeted area, not because of the other environmental things. It's open question actually for depression treatments, that the response rate we are seeing, or the good response we are seeing, is because of all environmental things, because the patient would go clinics every day for days or weeks, so it has other impact, or it's just because of the stimulation of the brain. If you have a good coil, which can, let's say, stimulate all off-target things and minimize the placebo effect, would be very beneficial. So you can, let's say, relatively easily model the placebo effect and say that the response rate I see because of this protocol, this treatment, it's not because of the environmental effects or the placebo effect of the coil. Maybe it's because of exactly the treatment I'm giving to the targeted area.
Okay. One of the questions that came in dealt with, we've tried this on TMS and motor evoked potentials. Have we tried this with TMS EEG at this point?
We haven't tried, to be honest, but I do not expect any issues with TMS EEG things, because the field generated with the sham one, I mean the off-target field with sham one, is similar to real one, so should not see any significant artifact because of the sham coil we have in here. So the artifacts would be exactly same as the standard TMS coil.
Great. That is through the list of questions that had come in, and a couple that I had added to it. Fantastic answers, Majid, and thank you again for your great presentation.
Thank you, John. Thank you, Ronnie.
Thank you both so much. Thank you, team at Magstim, for making this all possible. And thank you to those of you who tuned in. If you have questions, additional things you think of, please just reach into us.